Hello students, so in this lecture I will tell you the different guidelines or strategies that should be used to disconnect any target molecule. So some of the guidelines are now the first guideline, that is, if you are disconnecting any target molecule, then the starting material that you are getting, that should be workable and reliable. Workable means using that starting material should be easily available, that should be economical one, and using that starting material, the yield of the product that you are getting should be good. So now the first one, now after disconnection, the starting material, or you can say the reactant molecule or reactants obtained should be reliable, workable, easily available in lab, and economical, and giving good yield. Okay, this is the first guideline. Now what should be the second guideline? The second guideline is we should see for the functional group in the starting material. So we should search the functional group in the starting material. So find out the functional groups in target molecule. The functional group, for example, it may be alcohol, it may be amine, it may be amide, it may be ester. So we should see for the functional group. Now after searching this functional group, now we should see which functional group is the reactive one, and the reactive out of that functional group, the reactive functional group, that should be disconnected first. Okay, now third one, the reactive functional group should be disconnected first. Should be disconnected first. So you will see not many examples here. Now suppose if you have an NO2 functional group, and if you have OH functional group. So out of this, NO2 being the more reactive, okay, so disconnect from that NO2 part. Okay. Now if you get after disconnection, if you are getting the positive charge on benzene ring, then that disconnection is favorable. So you will not do that disconnection. Suppose this is the molecule, if you are disconnecting it from here and you are getting positive part over benzene ring, then that is not favorable. All of you know the positive charge on this sp2 hybridized carbon, that is not favorable. So disconnection should not be done such that the benzene bears a positive charge. So benzene ring or phenyl ring, benzene ring should not bear positive charge after disconnection. Okay, now Now, if you see CX group in a target molecule, then that CX bond should be disconnected. So if we find CX bond in target molecule, here this X may be this nitrogen, oxygen, any heteroatom, nitrogen, oxygen, sulfur, phosphorus. So if we find a CX bond in target molecule, then it should be disconnected. Okay. Now, so we will see the example. We will see the example of this. Now, another guideline. Now, suppose if after disconnection, the starting material that you are getting is less reactive than the target molecule, then that disconnection is not favorable. Or we can say that the starting material should always be more reactive than the target molecule. Okay, so if the starting material is less reactive than target molecule, then disconnection is not favorable. So in such case, before disconnection, we should do the FGI. So here we need the FGI. So in such case, we should do FGI, functional group interconversion. Okay. Now, for example, suppose disconnection is not favorable, then we should do the FGI. In what case we should do the FGI? So I have already given a video on this functional group interconversion. You can see that one. So if you see, like what I told you, suppose if you have NH2 over this benzene ring, then here the FGI is needed, and that should be converted into NO2. Okay, suppose if you have group CH2 and H2, that can be interconverted into either amide, because this on reduction it gives the amine, and similarly it can be converted into C triple bond, this N. Okay, or if you have suppose if you have COH, and that can also be converted into C triple bond N cyanide. So because this on hydrolysis, if you think in a reverse direction, then Cn on hydrolysis it will give you the COH. Okay, and many more. This FJ, I have already given the video on this. Now let's see some example. Now if you see this first example, then where it should be disconnected. Now first of all, what I told you, we should find the functional group. Here the functional group is the ether, and now you will see that here CX bond, that is CO bond, is present. The CO bond can be disconnected. So either this CO bond can be disconnected or this CO bond, this can be disconnected. So you should think that from where we can disconnect it, either from this path or from this path. So we should disconnect it from this path because it is giving you this benzyl carbocation. So benzyl carbocation being the stable one, so that's why we should disconnect it from here. Now if you see this example, now suppose if I disconnect it from here, so the functional group present is ether, is the functional group. CO we should see for the CX bond also. This is the CO bond, this is also a CO bond. Now if you disconnect it from here, then the positive charge will come over this benzene ring, and that's, I told you, that's not a stable one. Okay, so that's why we should disconnect it from here. So from here you will get the synthon, positive charge over here, and negative charge over here, positive charge over here, and from that you can get the synthetic equivalent or reactant. H can be added over here and Cl minus can be added over here. Okay, similarly H can be added over here and Cl minus can be added over here. Okay. Now let's see this example. Now ether group is thiether is present over here, and this is the CS bond, this is the another CS bond. So which bond should be broken? No doubt we will not break this bond because it will give the positive charge over the benzene ring. So we should break this bond. So this will negative charge over here, positive. So for this synthon you can add H plus over here, you can add Cl minus over here. Now this example, if you will see, we have two functional groups, OH and this ether. Okay, now this being the more reactive one, this CO bond being this more reactive, we can disconnect it from here. Now from where we should disconnect it? From here or here. So we can disconnect it from here. This is the negative charge, this is the positive charge. And this will, over here you can add H plus, and here it will give you the epoxide ring. Okay. Now in next example, where the disconnection should be done, the disconnection that should may be done either from here or here. You can disconnect it from here. This will have the negative charge, this will have the positive charge, Cl minus OH. If you will see this example, then CN bond, the CN bond can be disconnected. No doubt you will not disconnect this CN bond, it will give the positive charge over here. So that's why you will disconnect it from here. So negative, this is positive, H plus and this Cl minus. In the same, if you will see this one, two functional groups are present, two functional group NH and OH. So CN bond that should be disconnected, being the more reactive, the CN bond should be disconnected. And if you will see, then this bond can be disconnected, negative, this is positive. Now one of the H plus can be added over here to get the aniline. Another reactant molecule is, you can add, this is the epoxide ring, that you will get the another reactant molecule. Now example number 8, if you will see here, then three functional group is there, this amine, this OH, this ether. Now you will see for the reactive functional group and CX bond. So the one of the reactive functional group, this is the more reactive functional group. So you will disconnect over here, negative charge, this will have the positive charge, epoxide. Now the molecule is divided into two parts. In another part, if you will see, then this molecule can again be disconnected. Okay, this molecule is again disconnected. So no doubt you should search for the CX bond. You should search for the CX bond. We will not disconnect it from here, and we can disconnect from here. So this is negative, this is positive. You can add H plus over here and Cl minus over here. Okay, so these are some of the examples, and these are certain guidelines. In next part of this video, I will give you some more strategy to disconnect the target molecule. Okay, thank you.